Hello everyone, very good evening. Welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you so that we can start with the session. Yes everybody? Hello. Everyone, am I visible? Am I audible? Yes students? Hello, Sukesh, Umar, GM, Sanjay, Sahaya. How are you all? So, let's finish this chapter today, right? As I promised that we'll finish. So, we are going to finish this chapter today, right? Okay, everybody. Right, everybody. Let's finish this chapter today, where we are going to discuss firstly about MOT. Most of it we have already discussed. If you have not watched, watch the last, like I have done till now 4 lectures of chemical bonding, and this is the 5th lecture of chemical bonding, right? So watch all the lectures of chemical bonding so that understanding will be better, right? Now MOT we are going to start firstly, then we are going to jump towards bond parameter, bond angle. In that we'll see Bend's rule, Drago's rule we'll see, right? After that we are going to do dipole moment and hydrogen bonding. So all the topics are small, right, but they are very, very important, right? Students usually skip these very, very important topics, and you will see in JEE mains they ask questions based on that, right? So that's why doing all the topics is actually very important for you, right? So, firstly, I just want to recap. I just want to see whether you guys remember this or not. So, psi and psi b are the wave function of atomic orbitals. Then psi star, then sigma star is represented by which of the following, right? So, we have discussed this, and this is the question of 2024 question. Everybody, you can answer this very easily, right? So, answer is that sigma star is going to be yes, psi A plus psi B, right? So wait a minute, psi minus psi B, this is going to be sigma star and this is going to be sigma. This does not have any value, this does not have any value, so answer will be B is the correct answer. Okay, so just to recap that, we discussed about that psi is, if it is added it will form bonding, if it is subtracted it will form anti-bonding molecular orbitals. So atomic orbitals will combine and they will form molecular orbitals, right? Like 1s and 1s will combine and they will form sigma 1s. 2s and 2s will combine, they will form sigma 2s, right? Sigma 2s and sigma star 2s, both they can form. But now the question is, ma'am, when p orbitals combine, they will form sigma or they will form pi? So, when p orbitals combine, both the things are formed. Even sigma, sigma star and pi, pi star, both are formed, okay? So, that you have to remember that when we talk about z orbital, pz axis, right? So, across the pz axis, right, what is formed? Sigma 2pz and sigma star 2pz is formed. But when we talk about 2py and 2px, in that case pi is formed. 2py and 2px, when 2py and x is overlapped, atomic orbitals are overlapped, then molecular orbitals formed are pi. Okay, with z 2pz it will be sigma. Now ma'am, how it is taken? It is taken that everything is going along internuclear axis z, right? So by convention it is taken that 2pz is going to form sigma, right? 2pz, this is by convention. They could have said 2py is forming sigma, 2pz, but the answer is that if I am thinking that these are along the z internuclear axis, then along z, that means 2pz will form sigma and rest of the 2 will form pi, right? What if they say that internuclear axes are not z, they are x, then 2px will form sigma and rest of the 2 will form pi. But that thing is not asked to you. What is important for you to know that sigma is formed by 2pz and 2py, 2px is formed by 2px and 2py forms pi, right? Now here what happens when bonding molecular orbitals are formed and when anti-bonding molecular orbitals are formed. In bonding, what is happening here? Both are being added. So here what you will have, it will add on, this will be minus, this will be minus, right? Clouds will add, they will not be subtracted. Here they are being subtracted. So when they will subtract, here you will have some positive and here you will have some negative, but overall some part will be cancelled with each other. So that's why you will have a node here. So basically in anti-bonding molecular orbital, to make it little more easy for you, in anti-bonding molecular orbital, this is negative, this is positive, this is negative, this is positive. That means two different phases are overlapped. Plus and minus are not representing any charges, they are representing the waves, crest and troughs they are representing, right? So positive and negative when they overlap, then you have the formation of anti-bonding molecular orbital. Now what you will see here, that in 2pz, I'll just write 2pz, in bonding molecular orbital, you have no nodes. There is no nodal plane here. Can you say any node here? No, right? There is no node present here. There is no point where electron density is 0. But if you talk about anti-bonding molecular orbital, right? Anti-bonding molecular orbital, then definitely nodal plane is present, right? Then definitely nodal plane is present. As you can see, one nodal plane is present. You can also write it here. One. How many nodal planes are present? One nodal plane is present in anti-bonding 2pz orbital. This question can be asked to you in the theory form, right? Then if you talk about 2px and 2py, similarly this will be x and y will be same, diagram will be same. When they combine together, they will have overall positive and overall negative. You know, in reality what kind of orbital, I'll show you in a better way what is formed here. Basically this kind of situation is formed. This will be overall positive and this will be overall negative. And there will be a nodal plane here in between, right? There will be a nodal plane in between. Let me just show you the nodal plane here. Here you will have a nodal plane in between. So just like I told you that bonding molecular orbitals may or may not have nodal plane. We have discussed in 1s bonding BMO didn't have any nodal plane. In 2pz bonding molecular orbital, no nodal plane is there. But when we talk about 2px, 2py, nodal plane is there. So we can say one nodal plane. One nodal plane is present here. Now if you talk about anti-bonding, right? Here basically what happens, rather than writing it like this, you can also write it like this. That it, you can also write it like this, that this is, wait a minute, okay, you can also write it like this, the way I am mentioning here, right? So you can also write it addition, this will be minus, this will be plus. So when two opposite signs are added, signs means these represents the wave functions, like wave is a crest or trough, that it is representing, the phases of wave it is representing, right? Positive, negative, when it is overlapped, it will definitely form anti-bonding because two opposite phases are being overlapped here. So in anti-bonding molecular orbital, what you will have, this kind of situation here, this will be cancelled, this will be cancelled, this will be cancelled, this will be cancelled, right? So hence you will have positive, negative, negative, positive, this kind of situation you will have here. Now can you see there are formation of two nodal planes here, one here and one here. So in this case you have two nodal plates, right? That you should remember, right? Okay. Yes, everybody, definitely I am here to guide you only, right? Yes. Okay, is that clear, everybody? Tell me, is that clear or not? If that is clear, then do let me know in the chat box if that is clear to all of you or not, right? So that we can start with the electronic configurations here, right? Now, major questions that they ask you either will be based on bonding molecular, anti-bonding molecular orbital theoretical perspective, or they can ask you simple questions based on the electronic configurations, right? For that, you should remember that up to 14 electrons, right? If it has up to 14 electrons, then electronic configuration will be 2, 1, 2, 1. This is what you have to remember. Ma'am, what is this 2, 1, 2, 1? So this thing is always going to remain same. Whether it's up to 14 or more than 14 or equal to 14 electrons, it is always going to be sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. And we also represent it like kk star. And this kk dash, you can say kk dash, contains 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Okay? It is always going to remain the same. But the difference will be here. Difference will be at this point. When you have less than 14 electrons, it will be 2, 1, 2, 1 means 1, 2, then 1, 1, 2, 1. This is how you should remember it rather than remembering it like this. Always 2 means px and py will always have same energy. They are degenerate orbitals. Pz has different energy, right? So when you have degenerate orbitals, write it 2px, this is 2py, this is also 2px, this is also 2py. Now because it forms pi, so you can write pi, here also pi, here also pi. Because lower energy means bonding, higher energy means anti-bonding, you will put staric here, star here. This one will be sigma 2pz, this will be sigma star 2pz, right? So this is how you're going to fill the electrons. I'll also show you some examples based on that, right? Now, next is when electrons are after 14 to 20 electrons when you have, right? So when it is less than or equals to 14, you will follow this sequence. When it is from after 14 to 20 electrons, then you will follow this sequence where this one is same, that is kk dash. This one, wait a minute, this one is 1, 2, 2, 1, that is 1, 2, 2, 1. Okay, everybody, is that clear? What is 1, 2, 2, 1? What is 2, 1, 2, 1? Yes, everybody in the chat box. Just give me a minute. Okay. Okay. Beta, tell me, is that clear here or not? We are doing two things here. That is, if it is less than or equals to 14 electron, it is 2, 1, 2, 1. If it is more than 14 electrons, it will be 1, 2, 2, 1. That's how we are going to remember it. Right? Good evening, Sumit. Good evening. So now, after that, you will also calculate the bond order. Bond order is half of number of bonding molecular orbitals minus bonding electrons minus number of anti-bonding electrons. That also we'll discuss, okay? So, One by one we are going to discuss. First is for O2. The reason why this theory was made to understand the paramagnetic character of oxygen. Okay, from this various questions are asked. Okay, so oxygen, firstly what you will do, whatever compound is given to you, first you will calculate the number of total electrons, right? So in one oxygen you have 8 electrons, in 2 oxygens you will have 16 electrons, right? Now when I say you have 16 electrons, now you are going to fill these electrons. Okay, so how the trick will be very simple, that 16 electrons you have, 16 minus 8 is equals to 8. Now you will see, ma'am, what is this 8? This 8 is actually sigma 1s square, sigma star 1s square, sigma 2s square, sigma star 2s. So 8 electrons are filled in kk dash. So that's why I'm already subtracting it. So always kk dash is same. So if you have more than 8 electrons, just directly subtract 8 from there. Why to write it and waste our time again and again, right? So I'll just directly subtract it, right? Now from here, once you have done, 8 electrons you need to fill. Now 16 electrons means it is having more than 14 electrons. So whenever electrons are more than 14, it will be 1, 2, 2, 1. That means 1, 2, I'll just draw it here, 1, 2, 2, 1, right? 8 electrons you have already filled. 8 electrons you need to fill, right? So it will be 1, 2. Now according to Pauli's, Hund's, all the principles will be applied here. So degenerate orbitals are fully filled, then you will go to higher energy. All the orbitals that are degenerate are singly filled firstly, then you will fill further electrons here. So till now you have filled 6 electrons. 2 more electrons, 1 and 1. Can you see unpaired electrons? And ma'am, what are these lines? What they do represent? Okay, what they represent? So 1, 2, 2, 1. So 1 is always 2pz. And 2pz is sigma. So you will say sigma 2pz, right? And 2, when 2 degenerate you have, that will be pi 2px and pi 2py. Now upper one will be the antibonding. So this will be pi 2py star, this will be pi 2px star, and this will be sigma 2pz star. So can I see there are 2 unpaired electrons in O2, 2 unpaired electrons in O2, so that's why it's paramagnetic, right? You know what is the next thing here? Because it's 2 unpaired electrons, so it is O2. Now next thing is, where are these 2 unpaired electrons? They are present in 2 unpaired electrons present in pi star 2px. This question can also be asked, pi star 2py. In these anti-bonding orbitals, you have these 2 unpaired electrons, right? So that is the reason O2 is paramagnetic in nature. Okay, right? Yes, if you have to answer me the bond order here, how you will answer? Bond order will be answered like this. Bond order will be, wait a minute, yes. Bond order will be, see in KK star, bonding, antibonding same, bonding, antibonding same, so we don't need to write it, okay? So we will directly write this one, right? So here bonding is 1, 2, 3, 4, 5, 6. So it will be 6 minus 2 divided by 2, that is 4 by 2. So bond order is coming out to be 2. That is the reason it has 2 bonds between oxygen, right? Okay, yes, everybody got it or not? Clear, is it? Clear, everyone? I think I am regretting now wasting my Sunday for you guys. I'll never do that again for you guys. I am literally right now I'm regretting why I wasted my plans, why literally I wasted everything for you today, right? So I think I should not waste my Sundays for you, right? Extra thing I don't think so I should do, right? Because when I go extra miles for you, I expect also you guys to respond, this and that, but nothing. No tension, ma'am, no tension. You teach, ma'am, don't care, ma'am. You teach, ma'am, happy for you, ma'am. You waste your life for us, ma'am, we don't care. Ma'am, you waste your Sunday, Saturday, last Sunday also I taught you, right? So I will never do that again. It's a lesson that I just got. Right? It's a lesson that I should got, it's high time I should realize that. No? I should realize that it's high time. Right? I thought, chalo, no issues. So helium-2, hydrogen helium. Helium is atomic number 2. So it is total 4 electrons. 2 heliums means 4 electrons will be there. Right? Now, you can't say, ma'am, 4 minus 8. You don't have 8 electrons fully here. So what you will do here, you will directly write here sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, right? Electrons will be 2 here and 2 here, right? So this we don't need to write. This is the simple electronic configuration here. So bond order is going to be anti-bonding minus bonding divided by 2, that is 0. Now whenever bond order is 0, it means molecule does not exist only. Molecule does not exist only. This molecule will not exist at all here. Right? Okay, this molecule will not exist here. Right? Okay, understood? Yes, because of you guys only I am teaching now. So, because of those students who respond, because of them only I am teaching. Right? I was telling other students who, ma'am, you waste Sunday, Saturday, whatever for us, ma'am, it's okay, ma'am. Doesn't matter, ma'am. Ma'am, we give ma'am 2 lakhs, 3 lakhs in our coaching institute. Ma'am, they don't waste their Sundays for us. Ma'am, you waste, we don't care, ma'am. It's okay, ma'am, you do that. Right? So, ma'am is really stupid to do that for you. Right? Ma'am should learn something from life, yeah? It's high time, ma'am should learn. Isn't it? So, but you know, few students who actually care, I get emotional by them. Just few students who care for me, who are like, ma'am, teach, we are here, right? For them, I am always they are the motivation source. So how can I ignore those students who actually care? They are actually the source of energy, right? Isn't it? So now when bond order is 0, molecule does not exist. When bond order is, let's say, 0.5, if let's say bond order is 0.5, in that case it will be an unstable molecule. It will be an unstable molecule when the bond order is 0.5. Clear, clear, clear is there, then it is paramagnetic. Okay, ma'am, then in always, ma'am, no, in any orbital, if there is unpaired electron, that will be paramagnetic. Okay, it's just that in oxygen it occurs to be anti-bonding where you have unpaired electron. The question that they ask is, oxygen is paramagnetic, statement true. It is paramagnetic and the electrons, unpaired electrons are in the anti-bonding orbitals, that is also true. So paramagnetic means unpaired electron. And in oxygen especially, they are in the anti-bonding orbitals, right? So that's why it is specified here. It's not like they can't be in anti-bonding, but it's that oxygen is very famous because of oxygen only we are studying MOT, right? Now, next is lithium 2. Now, lithium is Rather than lithium, we can, study something better. Lithium is such a boring compound, isn't it? Let's study something really interesting. Let's study Cn negative. I hope so it is not there. Yes, it is not there. Let's study something difficult, okay? Let's study Cn negative. Now, how you will do these kind of questions, right? Firstly, you calculate the number of electrons. Number of electrons are 6 plus 7. 6 is from carbon, 7 is from nitrogen, and this 1 is from this negative charge. So it will become 14 electrons, right? It will become 14 electrons. Now, out of these 14, you will subtract 8 electrons. That will become 14 minus 8 is what? 14 minus 8, that is 6 electrons, right? Now see one thing, right? See one thing. Whether we need to use 1 2 2 1 or 2 1 2 1. That is a major question. Now, whenever you are deciding, in an ion you are deciding which one to use, 1 2 2 1 or 2 1 2 1. You need to see one thing there, that when I don't add the electron, in a neutral state, how many electrons it had. So in a neutral state, carbon and nitrogen is 6 plus 7, that had 13 electrons, which is definitely less than 14. So less than 14 means you will use 2 1 2 1 here, right? Even equal to 14 will use the same. I am just giving you the method here. Method is that you will see in the neutral state what is the number of electrons. In the neutral state I will see. Again I am saying in the neutral state you will see, and then you will decide it will be 2 1 2 1, and here you are going to decide that this is 2 1 2 1, right? So here electrons are going to be 1 2 3 4 5 6. Very good, because there is no unpaired electron. It is diamagnetic. It is diamagnetic. This is another kind of question where paramagnetic and diamagnetic character is asked to you, right? Now, let's see for next one, that is N2 positive. For N2 positive, what you will have? 7 plus 7, 14 minus 1, that is 13 electrons. Isn't it? 13 electrons. Okay. Let's see that. Now, here also what you will do? 13 minus 8 electrons, that is going to be 5 electrons. Now, in the neutral state, it has 14 electrons. That's why we will use 2 1 2 1. Okay? So, here it will be 2 1 2 1. So, here number of electrons, 5 electrons you need to fill. So, it will be 1 2 3 4 5. So, we can say N2 positive is actually diamagnetic, right? N2 positive is actually paramagnetic compound. Paramagnetic compound, right? And here the unpaired electrons is in which one? This one is nothing but this is sigma 2pz. So here unpaired electron is in bonding molecular orbital. Bonding molecular orbital, that is sigma 2pz. This also they can ask you, right? Okay. If you see the bond order here, bond order will be kk dash 1s sigma star 1s 2s sigma star 2s, they will cancel eventually. And here in bonding you have 5, anti-bonding 0 divided by 2, that is going to be 2.5. Okay, that is going to be 2.5, and paramagnetic, very good, right? Okay. Now let's do for one more. Let's do for NO. Okay, shall we do 2-3 more compounds? Let's do for NO positive. Let's do for NO positive. Okay. Let's do it for NO positive. So NO positive, how many electrons it should have? It should have 7 plus 8 minus 1, that is 14 electrons, right? Here you can easily do mistake, okay? So 14 minus 8 electron is nothing but 6, 7, 8, no, 4, 5, 6 electrons, right? 14 minus 8 is nothing but 6 electrons you have. Now the question is whether it should be 1, 2, 2, 1 or 2, 1, 2, 1. Who will answer me this? Whether it should be 1, 2, 2, 1 or 2, 1, 2, 1. Any idea on that? 1, 2, 2, 1 or 2, 1, 2, 1? Everybody in the chat box. I'm waiting for your answers here. I'm waiting for your answers in the chat box, guys. Yes, everybody. Yes, students. 2, 1, 2, 1. Okay, chalo, let's see. Let's see. If you see here, how many electrons you have in the neutral state? In the neutral state, the electrons are 7 plus 8, that is 15 electrons. And I told you, according to the neutral state, you will have to answer. So for 15 electrons, do you have 2, 1, 2, 1 or 1, 2, 2, 1? For more than 14 electrons, you have 1, 2, 2, 1. So this will be chosen. This is not chosen. Okay? Understood this concept? Why I am again and again saying, see here I also taught you according to neutral state find out. Here also I told you according to neutral state find out. Here also I am telling you according to neutral state. It's just that in last two previous examples, neutral and ionic were giving the same pattern. But here, if you study 14 electrons here, you will say, ma'am, it should be 2, 1, 2, 1. If you see neutral state, it should be 1, 2, 2, 1. Okay? So, that is a mistake that you can do. That's why I asked you only. Okay? Wait a minute. Okay. It should be NO positive, right? Okay, yes. I think, yes. Now you will use 1, 2, 2, 1. 1, 2, 2, 1 you will use. That will be 1, 2, 2, 1. Number of electrons, how you will fill? 6 electrons here. 1, 2, 3, 4, 5, 6. That means this is going to be diamagnetic. Diamagnetic with how many number of unpaired electrons? No unpaired electrons. What is the bond order here? Bond order will be antibonding is 0 here, so it will be 3. So that's why NO will have 3 bonds here, right? So it will be bond order is 3. Okay? Yes, everybody? Clear, clear, clear. Now let's discuss about bond length, everything here, how it is related to bond angle. Okay, so I'll just give you proportionalities here, right? So when you calculate the bond order, that is more the bond order, right? Shorter will be the bond. That means bond length will be inversely proportional to bond order. Can you tell me how? Just take one example. Oxygen has bond order 2, nitrogen has bond order 3. So we know that double bond has more bond length as compared to triple bond, right? This has bond order 1. So it has even more bond length. So more is the bond order, less will be the bond length. If bond length is shorter here, more energy is required to break this bond. So when bond length is less, bond energy will be more. right? So you can say bond energy will be more. And what is observed that bond length and bond angle are inversely. Halaki bond angle actually itself is a different topic, right? Because it depends upon various factors that we are going to study, but the general relationship is bond length and bond angle are inversely proportional. Now from MOT what they can do is they can give you 3-4 compounds and they can ask you the bond order, compare the bond order, compare the bond lengths, compare the bond energy. This they can ask you, right? Okay, so the question 2023 is according to MOT, answer the bond order of the following is what? Right, so they have asked you 3 questions here. NO positive we have already done. So what I'll do here, wait a minute, what I'll do here, yes, okay. So one by one I'm going to take, because NO positive we have done already. O2, 2 negative, let's do that, right? O2, 2 negative, guys. Oxygen is 8 electrons, 8 plus 8, 16 electrons, plus 2, that is 18 electrons, right? Now these 18 electrons minus 8 is nothing but it is 10 electrons, right? Kk star we have subtracted from there. So now if you see, ma'am, how many, what is it 2 to 1 to 2 1 or 2 1 to 1? For O2, in the neutral state, you will have 16 electrons, which is more than 14. So, you will apply 1 2 2 1 here, right? So, that's why what I will apply 1 2 2 1, and here it will be 10 electrons you need to fill here. 1 2 3 4 5 6 7 8 9 10, right? Now we know that first 2 are always bonding, last 2 are, these are always anti-bonding. So bond order is going to be bonding minus anti-bonding. So it will be 6 minus 4 by 2, that is 2 by 2, that is 1. So for O2, 2 negative order is going to be 1. So this is eliminated, right? Now let's discuss for CO. Let's discuss for CO. How many electrons in carbon? How many electrons? Carbon has how many electrons, guys? Let me see if you're answering this. Directly proportional to bond energy, inversely to the bond length. Very good, very good, very good, Sukesh, very good. Okay. Now, who will answer me this? CO. How many electrons it has? Carbon has 6 electrons plus 8, that is going to be 14 electrons. Out of 14, you are subtracting how many electrons? You are subtracting 8 electrons that belongs to Kk star, right? Now that will become 6 electrons. Now, in the neutral state also 14 electrons it has. So, we will say 14 electrons means it should be 2 1 2 1, 2 1 2 1, 1 2 1, 1 2 2 1, sorry, 2 1 2 1, right? 6 electrons means 1, 2, 3, 4, 5, 6. This is anti-bonding. So, bond order is going to be 6 minus 0 by 2, that is 3. So, CO is nothing but it is 3. CO bond order is nothing but it is 3. So, 1, 3, it is 1, 3, this is eliminated. And NO positive, guys, we have already done here. I'll just move it there. NO positive, we have already done this here, okay? NO positive, we already discussed that bond order will be 3 for NO positive, right? So, it will be 3 here as well. So, answer will be A is the correct answer here, right? Okay, understood? Now, ma'am, this is a lengthy method, ma'am. Can I have an easy method? Yes, you can have an easy method. So, I'll give you a trick, okay, to answer bond order directly. Trick to answer bond order, because now the trick is so famous that it is so famous that MOT question is easy peasy, right? Because With the trick, if you can answer, it means it's really, really easy question, okay? So now this is 14 electron always correspond to 3 bond order. For 14, always the bond order will be 3, right? Now what we'll do? Below it's 15, 16, 17, 18, above it's 13, 12, 11, 10, and corresponding to that, you will have the bond orders. You can subtract 0.5 below and above, right? So it will be 2.5, 2, 1.5, 1. It will be 2.5, 2, 1.51. Now verify this. In O2 2 negative, you have 18 electrons. Bond order was coming out to be for 18 electron, bond order is 1. Is it 1? Yes. Is it 1? For CO, it has 14 electrons, and for NO positive, it has 14 electrons. So for 14 electrons, is it coming out to be 3? Yes, it is coming out to be 3. Right? So directly with this trick also, you can answer. Okay? Right? So let's do this question now. That is, this question is based on a statement: a pi bonding molecular orbital has lower electron density above and below the internuclear axis. Pi bonding molecular orbital, lower electron density above and below. Okay, pi star antibonding has a node between nuclei. That is true, right? So this is 2024 question, which is based on the diagrams, right? If you see here, pi bonding molecular orbitals has lower electron density above and below the internuclear axis. Above and below, right? And this is pi star antibonding has nodal planes. So firstly, let's discuss about the nodal planes here, right? So I'll just show you the nodal planes. Pi will discuss firstly. Pi was given, na? Pi was given. Pi is this one. Now, first question that they have asked you is based on bonding, right? BM. So they are saying that this is the internuclear axis, this is the internuclear axis. Above and below, the electron density is more or less. Electron density is more, and here you have a nodal plane. Above is more and below is more. That means first statement will be incorrect, that it has less electron density above and below. It has more electron density. The reality is that. For antibonding, no matter what, it will always have a node. Even in pi it has a node, even in sigma it has a node, right? So now let's come back to the question here. Pi bonding molecular orbital, lower electron density above and below, that is incorrect. Pi star has node between the nuclei, that is correct, right? So we can say statement 1 is false and statement 2 is the correct answer here, right? Okay. Yes, everybody. So one topic we have done. Now we are going to do bond angle. Okay, yes, Komakula, definitely will do that. We'll do that, don't worry. Okay, now tell me factors affecting bond angle, right? Shall we start it? Everybody, it's very interesting, very like really nice questions you will see here. Right? Very nice questions you will see here. Okay, one by one we'll do that, okay? One by one we'll do that. Okay, so examples. Now, one by one we'll see it is based on hybridization, lone pairs, sentimental atom electronegativity. So many factors are involved here. One by one we are going to look into it. First is based on hybridization what you have, right? So based on hybridization, bond angle is inversely proportional to the steric number, right? That means, as you can see here, steric number is increasing. Here steric number is 2, wait a minute, it is 2, 3, it is 4, it is 5, it is 6, right? Can you see here it is decreasing, right? So till here there was no lone pair, based on that it was decreasing, right? In bent V there is lone pair, that criteria is different, lone pair something happens here. But what you need to remember from here, that if I say this is SP, SP2, this is SP3, easy way to answer this is, in SP we know that it is 180, it is a linear shape, it is 120 degree, and this one is 109.5 degrees. Can I say that SP has greater bond angle then SP2, then you have SP3? That means more is the S character, more will be the bond angle. More S character, bond angle is directly proportional to percentage S character, right? Can I say bond angle is directly proportional to percentage S character? Can I say that? Bond angle is directly, remember this, we are going to repeat it again, okay? Drago's rule, Bent's rule are based on this particular thing. Bond angle is directly proportional to percentage S character. More the percentage S character, more will be the bond angle, right? So now I'll just show you one example here based on this. There is one example, right? Now how do you answer it, okay? Firstly you will see, let me just show you one question here, BeCl2 BF3 CH4, BeCl2 BF3 CH4. Now this I will not repeat again that how we will calculate the hybridization. We already know, we have calculated it before also. This is sp3, this is sp2 and this is sp. That is why the angle is maximum here. This is how bond angle works, right? Okay. Now this is when the hybridization is different, okay, when we say that hybridization is different. Now if I say hybridization is same, then the next step what we will see, if hybridization is same, then we will see the number of lone pairs on the central metal atom, right? Example I am writing for you, let's say you have NH3 and you have H2, okay, you have NH3 and you have H2. Now if you see this here, it has one lone pair, it has two lone pair, right? Now we know that both of them are sp3 hybridized. More the number of lone pairs, less will be the bond angle, because bond angle is inversely proportional to number of lone pairs if hybridization is same. Why it is so? Because lone pair will cause more repulsions. More the number of lone pairs, more repulsions will be there, angle will decrease, right? So that is why this NH3 is going to have more angle. Direct thing is, more the number of lone pairs, less will be the bond angle. We have already discussed in the last class that how lone pair repulsions we discussed in Vesper theory, we are going to cause more repulsions, right? Now third is, ma'am, hybridization is also same, right? Ma'am, I calculated the hybridization, that was also same. Ma'am, I calculated the number of lone pairs and bond pairs are also same, ma'am. Now what to do? Okay, now what to do? Now in that case, bond angle is directly proportional to electronegativity of central metal atom. Let me just show you some examples for that. Let's see, H2O, yes, okay. Now what about bond angle here? right? This you will see in periodic P block as well, periodic classification as well, right? Now all of them has 2 lone pairs because all of them belongs to group number 16, right? All of them belongs to group number 16. Hybridization is same in all of them, that is sp3. Because they belong to same group, so hybridization will be same here, right? Hybridization is same, number of bonds are same, number of lone pairs are same. Now what to do? Now I'm again saying lone pair should be there. Number of lone pairs and bond pairs both should be same, right? If both lone pairs and bond pairs are same, in that case more is the electronegativity, more will be the bond angle. So that means down the group what is happening, electronegativity is decreasing, so it will be like this, okay? So down the group, this is group number 16, down the group electronegativity decreases, so this angle also decreases, okay? This angle also decreases, right everybody? Okay, understood? Wait a minute, let me also show you one more thing. Yes, there is a very important point that you should write here in box, right? A very important thing that you should write here in box. If no lone pair is present, then here also, here the lone pair are different only. Here third point where the lone pair I am saying must be present. If at least one lone pair is present, only then I can say yes, I can apply this particular relation here. If no lone pair is present, then this point is not valid. Then you can't find the bond angle with this. Like for example, let's say, ma'am, I have CH4, right? Then you have some other, let's say, where should hybridization? SiH4, okay? GEH4, so I'll write for example, CH4, SiH4, GEH4. In this point is not valid because there is not even one single lone pair here. So lone pair should be there, at least one lone pair should be there, only then this relation is valid, okay? Now next is, when hybridization is same, number of lone pairs are same, number of bond pair are same, and central metal atom is also same. For example, you have H2O, then you have OF2. Out of this, OF2. Now here what will happen, this is the lone pair, right? Hybridization of both will be sp3. This will also be sp3, right? Lone pairs are same, bond pairs are same. What is different? The electronegativity of surrounding atom is different, the size of surrounding atom is different, right? The electronegativity of surrounding atom is different and the size of surrounding atom is different. Okay? Okay, everybody. Now, let's see this. What you will do. Okay, I think instead of H, what you should have is Cl2. Okay? OCl2. Because there should be some comparison now. Comparison will be between this only. Right? Yes. Now that also you can compare, but this is a better comparison because this is very near to each other. There too we know that electronegativity of fluorine is more and more is the electronegativity of surrounding atom, bond angle will be less, right? So if you compare OF2 and H2O, OF2 will have less bond angle. But what about chlorine and fluorine? Here, bond angle is directly proportional to the size. We know that size of chlorine is more, so bond angle will be more. Bond angle is inversely proportional to electronegativity. Fluorine has more electronegativity, so bond angle will be less. And that's how you can write this thing here. Right? Okay. Here also same thing. At least one lone pair should be present, then only you can apply this method. Otherwise, you can't apply this method here. Right? Okay? Now, is that clear everybody? In the previous case, but according to Drago, after H2 none has hybridization, they are same period. Which one you are saying, beta? Which one you are saying? Beta, don't confuse so many things, okay? Don't confuse. This is a method of doing that, right? I am not saying, ma'am, let's do this from the Drago's rule. That's a different concept, right? That's entirely a different concept to show you something else, right? To show you that how angles actually vary, how down the group angles are decreasing. You can use that, right? Angle actually is like that only. This will have a very high angle and suddenly it will drop. You can do this with Drago's rule also. I am just giving you one example that from this method how you can answer things, right? This is a way to answer this. But definitely from second period and below, Drago's rule will be applied there, right? And that's why bond angle will decrease there, right? But as of now, I am just telling you a point where you can answer things more easily, right? Okay? But if you want to use Drago's rule there, you can do that as well. Okay? Answer should be correct. That's the only thing. Right? Okay? Understood? Yes, everybody? Chal. Now, let's do this thing. Now, because of back bonding, in bond angles, you will have various exceptions. And that is the beauty of inorganic chemistry. A lot of exceptions you will have here. Right? So, what is back bonding? And how it is going to change the bond angle, right? So, back bonding can be considered a type of resonance. It's like a resonance only. What is it's like a coordinate bond. We know that in a coordinate bond, you have lone pair of electrons that is donated to B, right? But these lone pairs are fixed, right? That means once you have donated, you have donated. But in back bonding, what happens? It involves transfer of lone pair specifically from filled shell of an atom to empty shell of the adjacent. It is a kind of covalent bond only, right? It is a kind of covalent bond only, right? Then back bonding is of two types. First is central atom to side atom, then side atom to central atom. One by one with examples, we will see both the types. In back bonding, always remember what happens. Rich to poor, rich to poor. Donation is from rich to poor. It can be if you have a lone pair or a negative charge, it will be donated to vacant orbitals. Vacant orbitals. Okay. If there is no lone pair here, no negative charge, then it is not rich. If the other atom is not having any vacant orbitals, so it cannot accept the electron. So both the conditions should be there. The one who is donating should have extra electrons. The one which is accepting should have vacant orbitals, right? Okay. So now let's see. If you see the trend of acidity, right? Or you can say, what is a Lewis acid? Lewis acid is the one which has vacancy of, which is electron deficient, right? So we can say Lewis acid is one that is electron deficient. That is electron deficient in nature. So if Lewis acid is electron deficient in nature, That means this Lewis acid, more the electron deficiency, more will be the acidity, right? So we know that fluorine, if I don't write this thing, right? If I just talk about electronegativity, I'll say fluorine is most electronegative, right? This is how we make BF3, right? Fluorine is most electronegative, so the electrons will be here, right? That means the deficiency of boron will be maximum. Then chlorine is less electronegative, so at least the electrons will be somewhat here, right? Boron, further electrons will be here. Iodine, maybe further electrons will be somewhat here. So fluorine has the sheer pair of electron maximum towards itself. So that's why we are assuming that boron has to be most electron deficient in BF3. That is what we are thinking. But you know, in reality, what is happening? In reality, see, this thing is happening. This is boron. This is F, F and F. Now this fluorine also has lone pair of electrons, right? Lone pair of electrons. Now tell me, is boron electron deficient or not? How it is electron deficient? Boron has already a vacant orbital. Boron is 1s2, 2s2, 2p1. When it is excited, it will become 1s2. It will become like this. This is 1s, 2s, this is 2p. When the electrons are excited in the valence shell, it will become 1, 2, 3. Yes, everybody. Yes, the electricity went off. So now it's back. Everybody in the chat box, tell me. So we were discussing why the order is opposite and what is exactly back bonding, okay? So because fluorine has lone pair, right? Now these lone pair of electrons, if you discuss, this boron also has vacant orbitals. How boron has vacant orbitals? Boron has 2s and 2p. In the excited state, it is 1, 2, 3. So this is the empty orbital, empty 2p orbital. So this is 2p. Lone pairs of fluorine, if you write the electronic configuration, that is also in 2p. These lone pair are also in 2p. So because of this, what will happen? There will be 2p, 2p donation. So what will happen here? This 2p and this 2p, this lone pairs will be donated to this 2p, right? But ma'am, that can happen in chlorine as well. So what happens here? Boron always have 2p. But if you discuss about fluorine, fluorine has 2p, chlorine has 3p, bromine has 4p, this has 5p. And 2p, 2p which has nearly same energy, that back donation is good. That back donation is better as compared to 2p, 3p, 2p, 4p and 2p, 5p. So that's why here donation will be very good. And that is the reason, see, if someone you think he was poor, but now they won some lottery, right? Now they have so much money, now they don't need your donation. So that's why we were assuming that boron is poor, but now boron has someone to donate the electrons. This will also donate sometimes, this will also donate the electrons, and that is why boron BF3 is not that electron deficient. That is why this is going to be the new order here. because electron deficiency will be maximum in Bi3, then BBr3, BCl3 and BF3, right? Similarly, you have PH3 and PF3, right? Now, PH3 will discuss more about it in Drago's rule, right? But before that, let's discuss this PH3 and PPF3. So, expected order of bond angle is this one, but reality is this one. Now, why so? See, because phosphorus, if you see, it is making 3 bonds, H, 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 and here also it is making 3 bonds here, right? It has lone pair of electrons also here, right? Now what will happen, that these lone pair of electrons will donate the, basically not this one, actually yes, what will happen here, this is having lone pair of electron, here this is having lone pair of electron. You need to find out where the back bonding will happen. For back bonding, it's not like only lone pairs you need. You also need some vacant orbital here. Ma'am, can back bonding happen here from central to side atom? No. Because hydrogen does not have any vacant orbitals where it can accept the electrons, right? So, that's why here no back bonding you will see. No BB you will see. No back bonding. But ma'am, here who is vacant? Phosphorus already have lone pairs. Now understand one thing, if you see periodic table, this is the periodic table, this is nitrogen phosphorus. So in front of phosphorus you will see the d orbitals. So because of those d orbitals here, it is going to accept the lone pairs. Okay everybody? Understood? Yes students. Why it is going to accept the electrons? Because phosphorus has empty d orbitals, right? So because it has 3d series in front of it, so that's why it is having empty d orbitals. So that is the reason these lone pairs will be donated. Sometimes this will be donated to phosphorus. That is why back bonding will take place, and where back bonding is taking place, more the back bonding, more will be the lone pair, more will be the bond angle. So here back bonding is taking place, so that's why bond angle is going to be more for PF3 as compared to PH3, right? Okay, because of this back bonding, it is going to repel, right? And that is the reason bond angle will be more here, right? Then one more you can see. Let me see if there is one more example of that. That can be H2O, Cl2O and F2. H2O, Cl2O and F2. Now if you apply the methods that I told you, you will say, ma'am, in this one, ma'am, H2, Cl2, do you remember we have done this before as well? Do you remember? This I showed you here, this I showed you here. This was the case where we discussed about this. Now this is for sure, I told you that OCl2 is always going to be greater than OF2, right? Now let's discuss about H2 also. This is the expected bond order, right? The bond angle, the expected bond angle is this one. But in reality, what will happen here? Here something will be different. This will be Cl2O, then you will have H2O, then you will have F2. Okay? Understood? So this is going to be the angle. Now discuss about that, why it is so. Right? Now the reason is hybridization is going to affect a little bit. I'll tell you how. See, this is oxygen, this is Cl, this is Cl, this is two lone pairs of electrons, right? Okay. Now in this case, what will happen, right, wait a minute, let me just draw that here, because chlorine also has vacant orbitals now. Chlorine, see, I'll tell you how it has vacant orbitals. See, basically, if you talk about chlorine, hydrogen and fluorine, that is a different part, right? Fluorine will not have d orbitals in front of it. Hydrogen will not have vacant orbitals, but this chlorine will have vacant orbitals. Chlorine will have vacant orbitals now. Chlorine, because it is chlorine fluorine. Before fluorine you will have d orbitals. Because of that vacant orbitals, what is going to happen? It is going to donate the electrons here, and this will become O, this is Cl, this is double bond Cl, this is positive, this is negative. Now because of that, it will exist in what kind of hybridization? Here you will have one lone pair as well, 1, 2, 3. It will start existing in, here it was supposed to be sp3, but because of back donation it is existing in sp2. See, in back donation, this is the thing what happens. In back donation, the hybridization fluctuates a little bit, that is why bond angle changes, right? So here when it is donating the electrons, it shifted to sp2. That is why it has maximum bond angle. Now you'll just write hydrogen and fluorine, no vacant orbitals. No vacant orbitals. Oxygen also does not have any vacant orbitals. Back bonding is only taking place over here. Back bonding is only taking place over Cl2O. That's why the order compared to, if you compare differently, there I told you if you compare H2O and F2O, H2 is greater. If you compare Cl2 and this, Cl2 is greater. But if you compare Cl2O and H2O, then things will change here. How things will change? According to that theory, more the electronegativity, less should be the bond angle, but it's not so here. Right? So basically it's because of back bonding that things are changing here. Okay? Right, everybody? Is that clear? Yes, students? Clear, clear, clear? Okay. So let's do this now. Next is, let's do this question here. That is, I think we have done all of them, na? Yes. So next question is JEE 2024 question that says the correct order, increasing order of bond angles is what? See, bond angles, this is purely based on hybridization only. If you see BF3, right, it will be sp2. PF3, it will be sp3. ClF3, chlorine will have two lone pairs, it will be sp3d, right? So that's why angle will be sp2. If you increase it, sp2, this actually decreases, so it will decrease like this, na? So BF3, so let's draw the structure only. If you discuss about PF3, BF3, it exists like this, okay? Angle is approximately 120 degrees. If you discuss about PF3, now I know you will again question Drago's rule. If specifically Drago's rule is not asked, you can take it general so that your answers matches, okay? Right? So here you will see one lone pair here and 3 bond pair here, right? So this is the angle, it will be around sp3, this is sp2, this is sp3 hybridization, right? And this is Cl. In chlorine you have, it has 7 unpaired electrons, 7 outermost out of 3 when you minus, so it will be 2 lone pairs. So chlorine will have 2 lone pairs, right? That you will put over here. This also will discuss in Bend's rule. Why this is so? We'll discuss this in Bend's rule, right? So this is F and F. Now if you see this here, right, that will be F and F, 2 lone pairs. So it will be sp3d, right? that has an angle of 120 and 90 degrees both, right? So you can say maximum bond angle is between BF3, that is this one, then it is 109 over here, then it is ClF3, right? So answer will be C is the correct answer here. Based on hybridization we have answered it. Okay, we don't need to go beyond because anything else was not given to us. This we have already done, right? This we have already done. Acha. Can you tell me about this question here? Trend of bond angle is this. Why? Why it is H3BO3 has more bond angle? This you will study in P block as well. Again, this is based on, this is again guys, this is based on which thing? Yes, everybody? What is happening here? Wait a minute. Wait a minute. Yes. So it is based on back bonding. So boron, this is OH, this is OH, this is OH. Now boron here has vacant orbital and oxygen has lone pairs. So oxygen can donate and back bonding can happen. Because of back bonding, its hybridization will change, and that is the reason this will have more bond angle. But ma'am, over here why it is not so? Because if you talk about this one, this is OH, this is OH, this is OH, this is OH. Now in this case, that vacant 2p orbital is already having one OH extra. So that's why you have here negative also. So it is no vacant orbital here. So no back bonding, no back bonding. Okay. So when you are answering the concept of bond angle, you need to take care of back bonding as well. If there is back bonding, then the bond angle is going to increase in that case. Right, everybody? Got it? Understood? Yes, students? Beta, let's not mix block chemistry here. Inorganic benzene we'll discuss in P block, and let's discuss that in P block only. Right? Okay? Now, let's discuss dipole moment. So, dipole moment is the polarity that it is defined, and dipole moment is actually there is no chemical bond as such in reality. This is a hypothetical situation that we imagine, and here it is the product of charge and distance that is represented by this mu dipole moment, right? And dipole moment is always from positive to negative, always from less electronegative to more electronegative. Now let's discuss its units are 1 dabai, and 1 dabai are nothing but this much centimeter, this much coulomb meter. Coulomb is for charge, meter is for radius, right? Now let's see very simple question. Now from here you should know one thing, that what is the structure. Structure you will get to know from Vesper, VBT, you will get to know about the structure. Once you know about the structure, you can easily solve this. For example, this is boron, less electronegative to more, less to more, less to more. Then you will apply vectors here. Now when two things are at 120 degree angle, they will have a new vector formation which will be of the same wave, which will be of the same length. So this and this will cancel eventually, and the dipole moment is going to be 0. Just like here in case of water, you will have one lone pair here, one lone pair here, right? So it is from less electronegative to more electronegative, okay? Less electronegative to more, less to more. Then atom to lone pair. So it is atom to lone pair, atom to lone pair. So what will happen here? All of them will add up to form a really large dipole that is not equals to 0, right? So always remember it is going from positive to negative and lone pair to and atom to lone pair, atom to lone pair. This is the only thing that you should remember. The arrows you should remember, the vectors you should remember. Now if you talk about NF3, right? if you talk about, this is a very interesting question based on this NH3 and NF3, okay? Very important question based on NH3 and NF3. If you talk about NF3, right, this will be this atom, right? This is less electronegative. You know what I'll do? I'll draw NH3 and NF3 here. On the next page, I'll draw NH3 and NF3, so that comparison you can do easily, right? That which will have more or less dipole moment, because that is a very famous question. So this is H, H and H. Here this is F, F and F, right? Now what will happen, it is less electronegative to more. So this is less electronegative to more, less to more, less to more, and this is atom to lone pair. This is less to more because fluorine is more electronegative, less to more, okay, less to more, atom to lone pair. Can you see here nothing is getting cancelled? Here all of them are getting added up. This is forming one resultant, this is another, and this is forming one big dipole here. So mu is definitely not getting cancelled. Here this will have a resultant, let's say this one. This will have, let's say, this much. They will cancel, but it will also not be equals to 0. So this mu is not equals to 0. This mu is also not equals to 0. But one thing that we are sure of, that mu of NH3, because there is no cancellation, it is greater than mu of NF3. Okay? Dipole of NH3 is greater than dipole of NF3. Right? Okay, yes. Now let's see that here. Now next thing is, this is all the important points, theory points, you can read out yourself also, right? Now this is in organic chemistry what you have, right? So in organic chemistry if you have orthochlorobenzene, right? So this and this will add to give you this resultant, so mu is not equals to 0. In para, this and this will add to give you resultant because the angle is greater. This you will see in physics, in vectors. If the angle is greater, the resultant will have less value. Here the angle is less, so the resultant had more value. So here mu of, this is very important, that mu of ortho is greater than mu of meta. Now what about para? What about para? This is exactly opposite and they will cancel. So mu of para is going to be 0 here. Right everybody? And this way you can see different examples and whether their mu is 0, like you have H2 where you have linear shape and that is going to be 0. In CO2 you have a linear shape, so here both are same, so it is going to be 0. In BF3 you have trigonal, but in that case resultant is going to cancel the dipole of BF, right? In the similar way CH4 all the bonds are same, so dipole is going to be 0. CCl4 all the bonds are same, so dipole is going to be 0. So when all the bonds are same, dipole is 0, right? Now let's do this question here everybody. We are left with 3 more topics here, bends, Dragos, and then you have hydrogen bonding, right? So the dipole moment of this is greater than this. See, it's a very interesting question asked in 2025, a general question. It might seem that this is from organic chemistry, but this is from chemical bonding. So here what you have to do is, firstly make the structures, make the resonating structures. If you have this, the double bond, this is the double bond, this double bond will jump here, this will jump here. We'll also see this in organic chemistry. I'm going to start organic. So you know what I'll do? I'll just delete this one. I'll again take up this particular question in resonance. Why so? Because I have not taught you resonance yet, right? So in GOC, first lecture will be of inductive and hyperconjugation. Second lecture will be of resonance, right? There I'll teach you this exact question. Okay? Yes. Now, beta, are you guys there? Now let's see percentage S and percentage P character. If you talk about percentage S character, that is cos theta is equals to S minus 1 into 100. S is the S character that you have, right? Okay, how much S you have. Percentage P, this will represent how much P you have, right? What is the percentage of that you will have, right? Okay, so that's how you're going to answer this. Let's take an example of that. Now, I'll tell you one question to solve this one, okay? Let's take one question. I'll just take one question here to solve this one. Yes, let's take an example of which one? Let's take an example of this only. Okay, I'm going to take this example here, right? See, because this will be useful in Bend's rule, right? In Drago's also we are going to utilize this, right? So this percentage S character will give you a reason for Bend's rule as well, Drago's rule as well. Okay, so firstly I am going to move towards Bend's rule. So first is you have any atom here, let's say A, it is in this kind of situation. Now we know that this is axial, this is equatorial, this is axial, this is equatorial, this is equatorial. Now can you tell me, if I talk about axial, right? Let me just draw these, let me just mention the bonds here. If I talk about axial, this is the axial that you have, this one and this one is axial. Now in case of axial, what you have here? Yes everybody, in case of axial, can you tell me what is the angle here? The angle is 90, the angle is 90. So can I say cos theta is equals to cos 90, which is defining the S percentage. Cos 90 is nothing but it is 0. Cos 90 is nothing but it is 0. That means percentage S character in axial bond, that is going to be 0. Right? In axial bond, percentage S character is 0. Now let's talk about in equatorial bond. In equatorial bond, what is the percentage S character? Now in equatorial bond, this angle is, the angle in these equatorial bonds are 120 degree, right? So that means this will be cos theta is equals to cos 120 degree. 180 minus 60, isn't it? 180 minus 60, right? So cos 60 is nothing but, if you solve this, this is going to be 180 minus 60, that is nothing but it is going to be minus half. So we can say percentage S character is minus of half here, right? Okay, now I will solve this value here, that is, what was the value given here? It was S by S minus 1 into 100, okay? So I will solve it here, that is S minus 1, right? So when you solve this, the value of S is coming out to be 1 by 3, okay? You can solve it, do that yourself, है ना? 1 by 3 and solve it in percentage. S is coming out to be 1 by 3. The percentage will come out to be 33.33. So S percentage is coming out to be 100 divided by 3, that is 33.33. Now can you see what is this percentage for? If you remember, this percentage is SP, SP2, SP3. For SP it is 50. For this it is 25. For this is a 33.3. So can I say this is the same percentage as sp2? So that means on an equatorial bond, if I talk about that equatorial bond is sp3d, it is divided, this sp3d is divided into sp2 and pd. This sp2 is actually the equatorial bond that we have just calculated. It is coming out to be same as sp2, right? And pd is defined on the axial, and we can see here also it is 0, there is no s character here, pd no s here, and here also it is 0 s character. So you can understand this with both ways, that how when from the angles we are calculating the percentage s character, how on axial the s percentage is 0, right? Okay, are you able to understand this thing or not? Yes, everybody here, tell me if that thing is clear to all of you or not. Yes, everybody, tell me if this thing is clear or not, right? So that we can move with the Bend's rule now. Bend's rule is entirely based on this concept, because that is applied for sp3d, and we are going to specify few things there, right? So let's see what is Bend's rule. Okay, everybody, beta, please say something now. Don't irritate me like that, right? Don't irritate me like that. If you don't want to study, then tell me, then I'll just go. So I'll sit then. I'll relax. You tell me. If you want to study, tell me in the chat box. If you don't want to study, I'll just end the class. And I'll not complete the chapter, okay? What was required, I have done that till MOT. Rest is what I am doing is extra only. Do that yourself. Bend's rule, Drago's rule, there are so many videos on YouTube available for that. I think you can do that. This all things I can't do it daily. Okay, you don't want to study, fine with me, your loss, not mine. Okay, chapter ended, and that's it. PPT I'll provide you, right? This PPT I'll give you, do it yourself, right? That's it. Okay, chalo. Okay then guys, bye bye. I'll see you all in the next class. GOC I'll see if I want to do on YouTube or not, or I'll start directly. Bye bye. Unbelievable, guys. Unbelievable. Unbelievable. Clap for yourself, everybody. Clapping. Okay? Clapping. Now I'll see who will teach you GOC here. Okay? I don't want to say anything. Let's stop. I'll just see what is there. I don't want to say anything to you guys. For me, you are kids only. But I'll not say anything. मेरा ना दिल नहीं माना. My heart was saying that I should teach. That's why I'm not going. Right? But the kind of attitude that is showing, I feel like literally resigning and ending. Right? But you guys, awesome yaar, awesome. I mean, how stupid I am to waste my Sunday for you. I could be going there, going outing. I don't have a JEE exam. You have a JEE exam. I don't have a JEE exam. I'm still ruining my Sunday for you guys. Am I stupid? Yes, I am, definitely. Now, I don't guarantee to complete the syllabus, right? Because you don't respond anything here, right? You are like, you take everything for granted. I mean, how can you be so robotic, guys? I don't feel like teaching you. I will like, okay, Banks rule will do, Drago's rule will do, this and that will do, so that students can get what everything, you know, the questions, everything they can get, which is not usually provided. Chalo, no issues. What's my, I got a lesson that on Sunday I should not teach you guys, right? At least on batch, Sigma batch students respect when I teach them on Sunday. You guys, I'll never teach you on Sunday. I promise you that, right? Now, I was like, I have promised them to complete chemical bonding. I'll do that. No matter I have to take extra classes, I'll do that. I had a family function yesterday. I still taught you. I had a family function, guys. I still taught you. I know how difficult it was. Today, it is Sunday. It is off for me. It is officially off for me. I'm not getting paid for this. Stupid people, stupid students, don't know what they are thinking. You have not done anything in your life and still that much attitude you are throwing on me. It's better not to give you that much so that I also relax. Now my whole week is ruined because of you guys. It's better I should have taken the class tomorrow or I should have taken it to next week. Why I am bothered about that your organic should be completed on time, your syllabus should be completed on time. Why I should bother about it? Have you paid anything to me? No. I should only care about Sigma batch students. But I am also caring about you. Why? Stupidity, na? Stupidity I am throwing. Today, I don't want to extend this lecture, so I'll teach whatever I prepared for you guys. It's okay, you don't want to respond, it's okay. It's totally fine, it's your wish. I never expected today's lecture I'm going to feel this way. I felt this way on NEET and I stopped teaching on NEET. Now, do you want me to stop teaching on JEE? I'll do that. I have batch classes, I'll teach there only. Right? Now, NEET students come and they ask, Ma'am, why you are not teaching on NEET? Because you never responded. You never respond. When you disrespect a teacher, how long the teacher can have patience and teach you? If you don't know how to respond, you don't know how to say yes ma'am, no ma'am, you don't care that I was scolding you for that. You don't care enough to say even a thing about that. Now, do that. One time we'll also stop teaching on JEE. Now go and watch the go and watch the videos of Vedantu NEET English. They're literally saying, ma'am, please teach. But to whom should we teach? Whom should we sacrifice our personal life for? For the ones who don't even reply? For the ones who don't even respond? Even now, like, you know, big losers, you guys are not even reply for that. Chalo, theek hai. Beta, tell me, do you want to learn something or not? Do you want, if this is yes, then write yes. If you don't want to learn something, then write no. This is not a tamasha going on here. You guys, na, really, you makes me question my life choices. I don't think so I'll be able to teach online more than 2-3 months. You guys, you only want one thing, a popular teacher who should dance on reels. This is what you want. You don't want study, guys. You don't want that. You make me question my life choices. Whether I should be teaching for free or not. Sometimes I feel I should not be. I genuinely feel that. So let's see applicable. Now what is Ben's rule? Okay, let's understand that. Ben's rule is when we say that electronegative element on axial and lone pairs on equatorial, right? So that is the reason whenever you have let's say ClF3, now in this you know that you have two lone pairs. So what you will do, this is Cl 1 2 3 4 5, fluorine will be on the, this is electronegative element, so that will be on the axial positions like this, right? And two lone pairs. Now you will say, ma'am, then there is this fluorine, why it is on the equatorial? Because first you will try to fill all of them on the axial, because there are only two axial positions and the atoms are 3, so that's why the third one will be here, and here you will have two lone pairs. Okay, that is the reason why this is the correct one and this is not the correct one. If you see this thing here, this is incorrect. If you see, this is the lone pair, this is the second lone pair, this is fluorine, this is fluorine, this is fluorine, that is wrong. That is the incorrect one, right? Okay, now let's discuss that modified version of Ben's rule. What is the modified version of Ben's rule, right? Right? Now modified version is more electronegative element occupies percentage S character, where percentage X character is more. Where percentage S character is more, or percentage P character is more? On the axial position. Haven't we seen that? Axial position was PD and equatorial position was sp2, right? So lone pairs and multiple bonds will be there on the, where you have more percentage S character, that means on the equatorial. This is another form, another way of writing this, right? This is another way of writing this. Let me just take out some examples here. Let me just see. Example is, let's say, yes. Okay, I'll just take out 2 examples here so that we can go beyond this, right? Now let's take out one example of SF4. SF4. So if it is SF4, if you see in SF4, there is one lone pair. This you can easily find from Vesper and VBT theory. There is one lone pair. It is trigonal bipyramidal geometry. Trigonal bipyramidal geometry, right? So it will be S1, 2, 3, 4, 5. Now, as we discussed that the lone pairs will be on that position where S character is more. That means on the equatorial position. So it will be like this and this. Now you will say, ma'am, this is same as like simple Bend's rule. Why you are saying modified Bend's rule? I'll explain you this with the help of one more question here, that is XCF5 negative. Okay, XCF5 negative. Now if you see XCF5, this has 8 outermost electron minus 5 plus 1, so it is going to be 9 minus 5, so it will be 4, that means 2 lone pairs. 2 lone pairs plus 5 sigma bonds, it will be 7. So here steric number is going to be 7. This we have discussed in the previous class as well. Okay. Now when the steric number is 7, that means this is xenon, right? This is in 7, right? What you will have here, this will be pentagonal bipyramidal. Okay, it will be pentagonal bipyramidal. So pentagonal means 1, 2, 3, 4, 3, 4, 5. This is the pentagon. And there will be bipyramid means here you will have one axial and axial. Okay, it can exist like that. Now where should you place the lone pair? Now if you just learn on the equatorial position, then pentagon is the equatorial position. Like for trigonal bipyramidal triangle, this triangle is the equatorial position. If you put here pentagon, then pentagon will be the equatorial position, right? If you just learn that lone pairs is on the equatorial position, then you will do it wrong. Because we know that the lone pair should be placed on where you have more percentage S character. See, here the angle in equatorial positions was 120 degree. Okay. So more is the angle. Do you remember I told you one thing, more is the angle, more is the bond angle. Bond angle in S character is directly proportional to each other. Do you remember when we did bond angle, I told you this thing. So that means more is the bond angle, more will be the percentage S character. Here at equatorial position, the bond angle is 120 degree and at axial it is 90 degree. But in pentagonal bipyramidal at equatorial position, and this is at axial position. At equatorial position, equatorial it has 360 divided by 5, right? That will be 72 something, and axial it is 90 only. So here bond angle is more on axial position. That means S character is more on axial position. So the lone pair will be there on the axial position. So here on the axial position you will have the lone pair, rest of them will be, if you write it here, rest of them will be your fluorine. Okay, so that's why we say that this is a modified version of Bend's rule, right? More where you have percentage S character is more, there you will place the lone pair or multiple bonds, right? You can see the difference here only, right everybody? Now we are going to do an exception, that is XCF6, right? This is an exception, XCF6. If you see here, you have total 8 valence electron, out of 6 is consumed, 2 electrons means 1 lone pair, right? So you have 6 bond pair plus 1 lone pair. You are thinking that it should be pentagonal bipyramidal, ma'am, same way it will be, ma'am, same way it will be, right? But it's actually not the same way. It's actually different here, right? 1, 2, 3, 4, 5. Wait a minute, here you should just not write this one, okay? Because it is carrying this negative charge here. Wait a minute. This is, steric number is 7 only, now 5. How many lone pairs? Wait a minute. Wait a minute. Wait a minute. It will have 2 lone pairs, na? 2 lone pairs it had. 2 lone pairs it had, na? So it will be like this, by mistake, right? Now this is having 7, so it should be pentagonal bipyramidal, but this is the exception. So here what kind of case it will form? It will be octahedral only, right? With an exception it is, so that's why we just have to remember this, that this is the exception, and here you will have the lone pair. That's why it will cause repulsion here and here, and that's why it will be distorted octahedral. Distorted octahedral. Okay, this will be distorted octahedral. Okay, everybody, that's it, right? So that was your Bend's rule, right? This is a question that is actually based on Vesper theory, mix it is. So here a molecular formula, this is given to you, elements, this is asked in JEE 2025. Element A is rarest, monatomic, non-radioactive from its group and has lowest ionization enthalpy value among A, and this element X and this have second and highest electronegative values among the known. What is the shape? Now from these hints, right, it is monoatomic, it is non-radioactive and rarest, that means they are talking about xenon. And rest of 2 are electronegative, but first and second highest. This will be first highest. That means they are talking about fluorine. Second highest means they are talking about oxygen. This compound they are talking about, and we already made this structure in the previous class, that it is going to be a square pyramidal structure. So answer will be B is the correct answer here, right? Okay. Now next is Drago's rule. Now Drago's rule, so many times like you are discussing about Drago's rule, let's talk about that. So Drago's rule is applied when center metal atom is third period or below, right? It is in the third period or below. Like you have phosphorus, or you can say it is the second element in its group, or you can also write it is the second element in its group. Like you have phosphorus, right? Right? This is for nitrogen, right? In oxygen we can talk about sulfur, so all these. Central atom must have at least 1 lone pair. Second condition is center metal must have at least 1 lone pair here. Surrounding atom has electronegativity less than or equal to 2.5. Third condition is surrounding atom should have electronegativity less than or equal to 2.5. Now, do you remember this thing you were talking about, ma'am? H2S, ma'am, H2S, then H2SC, ma'am, H2TE, ma'am, H2PO. Now, do you remember that why we were not applying Drago's rule here? Why I calculated the hybridization? Because there are conditions to apply Drago's rule. You just can't apply it everywhere. That it is a third period, so let's apply Drago's rule. The surrounding atom should have electronegativity more than 2.5. Okay, right? Okay, so that is not applicable there, right? Characteristics of molecules forming Drago's rule. Bond angle such as molecular approximately 90 degree. Such molecule does not undergo hybridization. Now let's talk about why this happens, right? So for example, you talk about phosphorus. Now this is the thing. NH3, PH3, ASH3, SBH3, BiH3. So we know that down the group it is decreasing, that's fine, but it should decrease to a certain level. Here it is, let's say 104 degree, it's not actually 104, it is 107 degree, and suddenly it is jumping to 94, then this is in between 93 or 92, it is also on the line of 90 only, right? So that means from NH3 to PH3 there is a very sudden big jump it has, big jump it has. Now the question is, ma'am, why it has a very big jump, right? Let's talk about that. Okay, everybody, firstly tell me if you're able to understand what is the question here, right? Okay. Yes, students. Now let me just let's see. Okay, let's do that on the next page. So if you talk about phosphorus, it is outermost electron will be 5 only. So you will have this thing here. 5 electrons means it will be, when it is jumped, it will be 1, 2, 1, 2, 3. Right? It will have this, like this. Outermost valence shell will be like this. Now, what we have observed is that the angle here was coming out to be 94. That means cos 94 degree. Cos 94 is nothing but it is S by S minus 1, right? Now when you solve this, your percentage S character will come out to be 2%, right? That means if I draw here, this is P, this is H, this is H, this is H, and this is the lone pair. If this angle is 94 degree, that means 1 pH will have 2% S character, right? 1 pH percentage S character will be 2%. For 3 pH bond, percentage S character will be 6%, right? That means for lone pair, because in this molecule what you have? You have pH or you have a lone pair. pH is 2%, 2%, 2%, rest of this will be 100 minus 6, that is 94% will be the percentage S character of this lone pair. Now this lone pair has 94% percentage S character. For SP also it is 50%. That means it is not even in SP, not SP2, not SP3. As you go beyond, as hybridization increases, steric number increases, the percentage S character decreases. So that means this says that it is a pure S orbital, right? This says that it is a pure S orbital. So in reality what is happening? There is no hybridization. No hybridization that it is undergoing. No hybridization that it is undergoing. And hence, right, this is your lone pair. This is your lone pair, and these three are making bonds with hydrogen. Okay, this one, and this one is making bonds with hydrogen. Okay, got it? Understood? So this is what we define in Drago's rule, right? This is what we define in Drago's rule, guys. Tell me if that is clear or not. right? Okay. Yes, everybody. Okay, understood now? Now if you see what is the difference in NH3 and PH3. Here is a very important question. This is of sp3 hybridized. This is pure s orbital. Pure s orbital. Right? That is the reason here it is having trigonal pyramidal structure, and here it is not defined. Okay, in some books you will see it is written as pyramidal, but it is not as such defined. Okay, now here you will see the angle is 107 degrees and here the angle is 94 degrees, right? Here lone pair donation is tough. Is easy. Lone pair donation is easy. Here lone pair donation, because s orbital has, you know, have full hold over this lone pair. That's why lone pair donation is tough. Okay, so lone pair donation is more, right? Because lone pair donation is easy, and for a base it donates the lone pairs, right? So tell me, in this case what you will do? Base, which base will be, which will be a better base, which will be more basic, right? Which will be more basic? Which one will be more basic? So here we know that Lewis acid is electron deficient, right? And Lewis acid wants to accept the electrons and this wants to donate the electrons. So here it is easy, so it will be a better base than PH3. Okay, these kind of questions they can ask you based on Drago's rule, right? Chalo. Now that's it. Last is very simple, hydrogen bonding it is, right? So hydrogen bonding is a type of weak chemical bond that occurs when hydrogen atoms, so basically hydrogen bonding, let's say this is H and this is X, it will occur only if an electronegative element is attached with a covalent bond through, okay, you can answer it like this. You have HX. If hydrogen is attached to an electronegative element and it is in the space of an electronegative element, then this kind of bond is called hydrogen bond. Okay, but the condition is if this hydrogen can only show hydrogen bonding if it is also covalently bonded to an electronegative element, right? And those electronegative elements can be phone, that is fluorine, oxygen and nitrogen, right? Okay, now let's see. Condition is presence of H in an atom, presence of highly electronegative atom, covalent bond between H and NOF. That is very important. Usually students skip that, right? This is very important. That's why if you see ether is this thing. Ether will show van der Waals forces. Ether never shows hydrogen bonding because this hydrogen is not bonded to any electronegative element, right? So it should be bonded to electronegative element, only then it can show hydrogen bonding. Lone pair on the electronegative atom forms hydrogen bond with oxygen. So lone pair on the electronegative, how does it form? Okay, lone pair on the electronegative atom forms hydrogen bond with the hydrogen, right? Now two types of hydrogen bonding, and this is very famous. Two types of hydrogen bonding you have. First is intermolecular. Intermolecular means within two molecules, right? So wait a minute, same diagram it is. No, that is wrong. Wait a minute. Let me just show you that. What is intermolecular? molecular and what is intramolecular. Okay, so if you see, this is OH, right, and let's say this is NO2, right. This is another molecule which is NO2 and this is OH. So now this hydrogen that is attached to an electronegative element will form a hydrogen bonding with this oxygen here, or with nitrogen also it can show, right, whatsoever is in like space, right, whichever orientation is better, right, and this hydrogen will show, this hydrogen here also will show hydrogen bonding with this NO2. That is called intermolecular. Within two molecules it is showing hydrogen bonding. So para nitrophenol, this we'll discuss in organic as well. This is a very major application of this thing in organic, right. So para nitrophenol shows intermolecular, and intramolecular means within its own molecule. So this OH, this hydrogen is going to show hydrogen bonding with this oxygen of the same molecule. Because it is at ortho position, the orientation is better so that it can mix and give hydrogen bonding, right. So this is also hydrogen bond because it is occurring within the molecule, so it is intramolecular. Okay, this is intramolecular and that is your intermolecular, right. Okay, and that's it. Now let's see some questions based on this. So the question is, the correct statements about hydrogen bondings are what? Hydrogen bonding exists when hydrogen is covalently bonded to hydrogen highly electronegative element. Yes. Intramolecular is present in ortho. Intermolecular, no. Intermolecular is present in para, not ortho. In ortho, this was ortho, na? This is at ortho position. This is ortho position. So at ortho position, intra is present, and ortho, para, everything we'll discuss in organic chemistry, right. Intramolecular is present in HF. Intramolecular definitely not. In HF, intra, in one molecule it is not present, it is present between different molecules. The magnitude of hydrogen bonding depends upon physical state of the compound, right. Yes. Then hydrogen bonding has powerful effect on the structure and properties. Yes. So we can say A, D and E is the correct statement here, right. Okay. Next is based on, this is JEE 2025 question. So this is based on H2O, NH3 and CH4, right. So all the different things that we have discussed in P block, in chemical bonding, they have shown this here. First is center metal atom of the molecules are sp3. Is it sp3? Yes. This is from Vesper VBT, you know that it is sp3. Now HOH, HNH and HCH, angles above the molecules are, okay. So in CH you have 109, here you have in ammonia you have 107 and here you have 104, that is also correct. We have seen this in bond angles. Increasing order of dipole moment. Now dipole moment, this I showed you in dipole moment that in NH3 you will have one dipole and this is H and this is H. In OH and this, it will be like this and like this. So it will be added. Here it will go like this, positive to negative. Here also it will be added. Here also it will be added, right. And here CH4, all the atoms are same, this will be less, right. But what about H2O and what about NH3? Which one will have more dipole moment? So definitely H2O will have more dipole moment, right, because two lone pairs are involved here, right. Okay, so Hello. Till when you were not able to, okay. Hello. Now is it audible? So, I think the battery went off. Okay. So, what I was discussing, first is they talked about sp3 hybridization, all of them are sp3. Then they discussed about bond angles, that is also correct. Dipole moment also I showed you that this is correct. More the lone pairs, more will be the dipole moment, right? If the hybridization is same, right? So that is also correct. This one is not correct because these two are Lewis acids, definitely not. Lewis acids are electron deficient, they are not electron deficient. Then we talk about last, that is Bronsted acid and base. So I am just telling you that this statement is not correct because Bronsted acid, Bronsted base is itself a topic, right? We will discuss about that in ionic equilibrium, right? Then I will tell you why NH3 in water is basic. In the solution NH3 and this act as Bronsted acid and base respectively. In the solution NH3 act as Bronsted acid and H2 act as base. That is not correct. NH3 act as a base. Right? Well, we know that NH3 is a base, right? But here we are saying that Bronsted base, right? We will talk about Bronsted base also in detail in ionic equilibrium, right? But from here also you will get a hint that NH3 is not a base, is not an acid, it's a base, right? So that statement is incorrect. So that's why answer will be A, B, C are the correct statements here. So answer is C is the correct answer. Okay? Understood? Yes. So guys, that's it. Now this is your homework question, right? You need to answer me the bond pair ratio lone pair, right? And options are these. These are the options. Out of this you need to answer me in the comment section which of the following is the correct answer here. You can take the screenshot and answer me that. Now before going, just remember that there is MD SAT scholarship program that is happening on 4th, 5th, 10th and 4th, 5th, 11th and 12th of October. It's Saturday, Sunday only, so you can easily manage that. Now this scholarship program, Mega Vedantu scholarship admission test, what is the benefit of that? You will get 150 crore worth of scholarship and 2 crore worth of prizes like iPhone, iPads, all these things you will get if you are among the 2.5 lakh test takers, right? And that is itself a big deal, right? So what you need to do is register yourself. Registration is absolutely free of cost, and then give the test. The test you can do online also, offline also. Preferable is offline because more benefits you will get when you give the test in offline. Okay? Yes. Okay then guys, and now the session is done. Okay, that's completed. Chemical bonding done. Now we'll start GOC from Wednesday. Right? Till then, bye bye. Take care. I'll see you all in the next class.